Kirchoff's laws, very important. They go hand in hand with Ohm's law, and it enable us to solve circuits consistently and accurately. Gustav Robert Kirchoff was born 12 March 1824 and died on the 17th of October in 1887. He was a German physicist who contributed to the fundamental understanding of electrical circuits, spectroscopy, and the emission of black-body radiation by heated objects.
Never gonna take the grind. Never gonna take the grind. Never gonna take the grind.
His circuit laws apply to series and parallel circuits. Here we have examples of series and parallel circuits. Here we can see that in the series circuit, we have R1 and R2 and R3, each connected together in a series closed loop. And they are energized by a voltage source of magnitude E. The parallel circuit at right has the same battery or same source of DC voltage, but it has two paths that are in parallel, like two pumps that go out from a source and then return to that source. So at left we can see that the voltage E is going to be equal to V1 plus V2 plus V3, the sum of the voltage across each of the three resistors in the closed loop. But at right, we know that what goes out of what's drawn from, is a better way to put it, from the battery splits into two paths. Some of the current goes through R1 and some goes through R2. And so more about these configurations in the next slide. The voltage law applies to the series circuit, and it says that the sum of the voltage drops around a closed loop is always 0 volts. Now, I've drawn the arrow directions. You can see that as far as the loop is concerned, the arrow of the beside the source voltage points in a clockwise direction around the loop, whereas the arrows through the two resistors that are in series. And by the way, the current is the same through the 3 ohms and the 2 ohms because, well, we'll see that in the next slide when we talk about his current law. But in any case, they're counterclockwise in direction. So typically, we would use 10 volts, and then we would say that the voltages in the other side are negative because they're in the opposite direction. And when you sum them together, you get an algebraic sum of 0. Now, the current law is more intuitive. It just says you can't have current into one single point. It has to go somewhere. It just doesn't disappear into a black hole. The current law says that the sum of the currents into and out of a circuit node are always 0 amperes. So here you would say that in this case, one of those currents that's going into the node has to be negative. And what negative means in this case is we've drawn the arrow the wrong way, and we need to reverse the head of the arrow to the other end. Could be any one of those currents.